Okay, I'm not going to read the problem. You need to do that on your own. 2008 Form B, problem number 5. This is one of the more challenging problems that we cover, and it's going to be really important for you all. So, when I read the question, it says, what is the distribution of y minus x? Well, first off, I need to identify what y and x are. And it says, assume the length of time y for the train leaving Diamondback. So y is Diamondback, and I'm going to go ahead and record the important information. And the important information is the mean is 200 and the standard deviation is 10 minutes. When it talks about x is bull snake, and it has a mean of 170 minutes with a standard deviation of 20. Now, it says, what's the distribution? Well, I need to know the shape that we're beginning with. Well, they tell me right away that it's normal. So consequently, we're going to be working with a normal, and it says y minus x. Well, the nice thing is I can sit there and go, well, what's my mean going to be? Well, mean's going to be, in this case, 200 minus 170. This is going to be the mean of y minus x, and that's just going to equal a positive 30. So that'll be the mean of it. But the standard deviation is a little bit different in that we can't directly subtract. So they're asking for the standard deviation of y minus x. So 10, and then we have the 20, but we can't subtract them, we can only add them, but we must square them first and then take the square root of them. So when I do that in the calculator, 10 squared is obviously 100, plus 20 squared is going to be 400, so that gives me 500, so the square root of 500, and that is 22.36. So the standard deviation is going to be 22.36 for this distribution. Then it says, and you're going to need to know how to do that this type of problem for your FRQ. Over the long run, what proportion of the days, and it says proportion, so it's asking for probability, will the train from Bull Snake have to wait at Copperhead for the train from Diamondback to arrive? Well, first off, they told me it was normal above, so consequently I'm working with a normal curve, so I'm going to start with my little picture. And I know that my mean is 30. Well, anytime they tell me something's normal, the very first thing I do, or one of the first things, is I write x minus mu over sigma. Well, and then I start plugging in to see what I have. So I know I want the probability, and what do I have? I know my mean is, in this case, 30, and I know my standard deviation, we just calculated in part A, is 22.36. But I don't have a z and I don't have an x, so what other information do we have? Well, they want to know the time it'll have to wait. Well, if this is 30 minutes it has to wait on average, I want to know anything above 0, because obviously at 0 minutes no one's waiting. So I'm looking for this area up here. So I'm going to want the probability that z is greater than or equal to 0 minus 30 over 22.36. So when I go to my calculator, and since I'm looking for a probability, this is going to be a normal CDF, second vars, normal CDF. My lower bound in this case, if I look at my shading, is 0. My upper bound is 30, and my standard deviation, and my upper bound is infinity, so I need to load that up with a bunch of 9s. My mean is 30, and my standard deviation is 22.36. And so we end up with a probability of 0.9102. So about 91% of the time, the train will have to wait. Okay, so then we move on to part C, and part C says, how long should the Snake Gulch Railroad delay the departure from Bull Snake so the probability it has to wait is only 0.01? Well, that's kind of a little bit difficult to start with, so we'll go back to our initial drawing. Our initial drawing said that we had a mean of 30. We know our standard deviation from above was 22.36 and 0. That was when we shaded it this way. It was like that's how much of the time they were waiting. So they're waiting 91% of the time. I only want to wait 1% of the time, so I need to decrease this shaded area to make it only 1%. So with it only being 1%, that's right here. So this needs to be 0.01. Now our calculators work left to right, so I'm going to need to work with 1 minus 0.01, which is 0.99. So this big area right here is 0.99. Now, so let's start plugging in and see what we have. So we have z equals x minus mu over sigma. So I want the probability that z, and then we have x is what we're looking for. We don't know 30, and we don't know our, and we do know our standard deviation is 22.36. And since we're working from this way, we want to be greater than, greater than or equal to 0.99 because we're working from left to right. So it equals 0.99. Well, the fact that I have a probability, I need to convert that to a z-score. To convert it to a z-score, I'm going to need to use, anytime you take a probability and converting to a z-score, it's an inverse norm. So second vars, inverse norm, area is 0.99, 0.99, and we end up getting 2.326. So 2.326 is greater than or equal to x minus 30 over 22.36. At this point, I can solve by algebra. I'm going to choose to use the calculator to do this. So I can go second vars, inverse norm. I already have the 0.99 in there, and at this point, I'm going to go ahead and plug in my mean of 30 and my standard deviation of 22.36 for the actual values because I want the actual value. And so 82.017. So this right here is 82.02. So the train would need to be delayed about 82.02 minutes. Okay, thank you.